All right, the reason why I wanted to kind of jump ahead to what we would normally cover during pry time is because we need this portion of equations, and this lesson on equations, to incorporate into our angles unit, okay? We have covered everything that's going to be on your interim so far. All the material that's going to be on your interim has officially been covered. Your interim is in 2 weeks. So we're going to do some basic skills practice still, and then a nice thorough review prior to the interim. But everything that we have covered is up for grabs on the interim. So what I wanted to cover with you today for your equations unit that would normally be in your pry time is variables on both sides. It's a part of that multi-step equation process. Variables on both sides is just an additional step that exists, but there is a process to working this out. So if I give you a simple variables on both sides equation, negative 6x plus 12 is equal to 3x minus 15. This is a simple equation, but it is considered to be multi-step because it has the variables on both sides. So in a situation like this, when you have your sides simplified as far as they can be, and by simplified I mean you have one coefficient, one variable, and one constant on the left side, and possibly one coefficient and variable, definitely a constant, on the right side. Okay, when it's simplified, you cannot combine like terms anymore on the left, you cannot combine like terms on the right. This is as simplified as it's going to get. That's when you start doing the process of, maneuvering to get the variable over to one side. So in order to move any variable terms, so we know if we want to move a constant, we have to add or subtract. We know if we want to isolate a variable, meaning get the variable by itself, we would multiply or divide. But if we want to actually move the variable, that also is going to require addition or subtraction. So again, if we want to move a variable term, like for example 5x, if I wanted to move 5x to the other side of my equation, if I had a 5x there, then I would have to do so by adding or subtracting. Because I'm not trying to get the coefficient gone. I'm not trying to get the variable by itself. I'm trying to actually move the entire term, the coefficient and the variable. Only way that you can move things from one side to the other is through addition and subtraction. Okay? So you would have to add or subtract the term to both sides. Now, a lot of times people get confused, well, which one do I move? Do I always have to move the one on the right? Do I always have to move on the left? My suggestion to you guys, because it's a newer concept, and you guys aren't always so great with negatives, I always suggest that you guys move the smallest of the variable terms. By moving the smallest of the variable terms, it lessens the chance that you have to deal with a negative when it comes to a coefficient. Okay, so I'm going to put that down as a suggestion. Move the smallest of the variables. Again, you don't have to. Some people prefer to always take the one that's on the right and move it to the left because they like having their variables on the left side. They like their final answer to say x equals. But if you don't want to deal with negatives, then just choose the smaller of the two variables to move. So if we have a negative 6x plus 12 is equal to 3x minus 15, my two variable terms are negative 6x and positive 3x. So what's smaller, negative 6 or positive 3? Negative 6. A negative is always going to be smaller than a positive. A negative is always going to be smaller than a positive. Okay, so I'm going to go ahead and what's the opposite of a negative or a minus in front of it? The opposite would be what? What's the opposite of a negative? A positive. What operation is positive? Addition, plus. So we're going to add 6x. We're going to add 6x to both sides. So I'm going to add 6x here. And then I'm going to add 6x to here. Not to my negative 15, because again, I'm combining my like terms. Right? I can only add 6x to another x value. These can cancel out. They are going to zero out. And what I'm left with now is 12 equals 9x minus 15. Now, some people look at it and go, I don't like having the x on the right side. I want it on the left. I got Mylan going, yeah. So, there's nothing wrong with solving it like this. There's also nothing wrong with going, I want to rewrite it, where I'm going to take the 9x minus 15 and put it here. And I'm going to take the 12 and move it to the other side. Nothing wrong with doing that. If your preference is to have it written this way, that is perfectly fine. I also prefer to have x on the left. I like for my answer to say x equals this, not this equals x. Okay? So once you rewrite it, if you choose to, you then would just solve it like normal. Okay, Elisa, what's our first operation? What's our first inverse to do? Add what? Once we've done this, what are we going to add to both sides to start isolating the variable? 15. We're going to add 15. Even if you had it on the original, you'd still be adding 15 to both sides. You're going to add 15 to both sides. Those will cancel out. You're going to be left with 9x is equal to 27. Malia, what's our next step? What are we going to do now? What operation are we going to do now to solve? Huh? What's the inverse operation here? Division. Did I catch you off guard? I'm sorry. X is going to be equal to 3. Be prepared, guys. I'm just going to start randomly calling on people. It doesn't mean that I don't think you're paying attention. I'm just going through my list. Okay? So that was the first question. Let's go ahead and have you try this one on your own. 8x plus 7 is equal to 5x plus 19. Go ahead and work that one out by yourself, and then we'll go over it together. All right, so the answer is 4. Let's go ahead and go over it. Again, like I said, I recommend move your smallest variable first. Which one is the smaller variable out of 8x and 5x? 5, right? 5x is the smaller. It's a positive, so the opposite would be to what? Subtract. We would subtract 5x. Subtract 5x from both sides. Those 5x's are going to cancel out. And then 8x minus 5x is going to give us 3x. We still have that plus 7 is equal to a positive 19. Okay, from here, next inverse operation is to what? Subtract. Right, we're going to subtract 7 from both sides. Those 7's are going to cancel out. We're going to be left with 3x is now equal to 12. And then the last step, divide. Okay. Divide by 3. X is equal to 4. Okay, let's go ahead and go over to, well, if you have room on yours, I don't have room. But remember, you can do what you wish on your side for this part. All right. Anybody still need this up here? 10 seconds. You good? You good? You good? Okay. Here we go. Now, this one's going to be a little bit more complex. Not too much more, but just a slight bit. 5x plus 4 minus 2x is equal to 6x minus 14. So, in a process like this, remember I told you last week during Pride time, you have to do before you can actually undo. Do means you've got to simplify everything you can on each side, meaning you need to combine like terms or distribute if you can, so that you simplify each side down to this format. The format that we always focus on is what we call AX plus B. AX plus B, that is a standard format where A is a coefficient, X is the variable, plus B is a constant. You want to simplify down to that form on both sides if necessary. Okay? So for here on the left side, we don't have it in AX plus B format. And really I should say plus or minus B, because it could be a minus as well. But here we don't have it in that format yet, but we can get it to that. So when we do means you are actually going to do the operation it tells you. You're not doing any inverses, you're not undoing anything. You're simply following what it tells you to do. So here we've got like terms of 5x and a minus 2x. Those are like terms. And I can write them side by side, 5x minus 2x. And simplify that. What does 5x minus 2x equal? 3x. Okay, now that plus 4, I don't have a like term on this side with it. So I'm just going to bring that down as plus 4. So now I have it simplified to the AX plus B format. On my other side, it's already simplified into AX plus or minus B. So I can just bring that down as it is. Okay, so I simplified, combined like terms, did the do portion of my solving before I go into the inverse operations, undoing things. Okay, so variable on both sides, which one's the smaller? 3x. 3x is smaller, so I'm going to go ahead and subtract 3x from both sides. That's going to leave me with a positive 4 is now equal to 3x minus 14. Mylin doesn't like it this way. She wants to rewrite. I want to rewrite too, don't worry. So I'm going to put 3x minus 14 is equal to 4. If you are okay with the way that it is, it's perfectly fine. Okay. Next inverse operation, we're going to add 14 to both sides. That's going to simplify to 3x is equal to 18. And then we're going to divide both sides by 3. And we'll get x is equal to 6. Now, the most complex that it probably would ever get involves combining like terms and distributive property and variables on both sides. That's the most complex you would probably see. So we're going to do one more example where it involves all of those concepts. Negative 5 plus 7x minus 3 is equal to 2 times the quantity of x plus 1. So again, before you can start undoing, before you can move things from one side to the other, you have to simplify both sides of the equal sign. So we're going to do what we can. So let's focus on the left side. What can I do or combine as like terms on the left side. Mylin? Good. Negative 5, subtract the 3, or, a negative 3 here. So negative 5 minus 3, that's going to come out to a negative 8. Now, that positive 7x is still going to come down as positive 7x. Equals. Okay, on this side, what are we going to do? Susanna? The distributive property. Distributive property says that I'm going to take that 2 and I'm going to multiply it with the x and with the 1. So I'm going to do 2 times x, which is going to give me 2x. And I'm going to do 2 times 1, which is going to give me 2. What operation do I put in between? A plus, because 2 is positive. Because the 2 is positive, I'm going to put a plus sign in between. Okay? I have both sides simplified down to ax plus or minus b. Okay? Now, first things first, which variable am I going to move? Omar. 2x. It's my smaller one. Let's subtract 2x from both sides. Okay, that leaves me with negative 8 plus 5x is equal to a positive 2. Now what am I going to do? Everybody should be looking up here. What do you think we're going to do now? Leona? Add 8. Very good. A lot of times people look and they go, well, wait, hold on. The constant's supposed to be in the back, and why isn't it in the back? It's okay. It can be rewritten this way if you want, or you could write it as 5x minus 8. It's still the same thing. But because the fact that the 8 is a negative, the opposite of it would be a positive, or just to add 8 to both sides. Okay, those 8s are going to cancel out. We're going to be left with positive 5x is now equal to 10. What's our last step? Samantha? What's the last step to do to solve? What's the inverse operation here? Opposite operation. Well, this is not addition. This is multiplication. So what's the inverse of multiplication? What's the opposite of multiplying? Huh? Division. Okay? So we're going to divide both sides by 5. Divide both sides by 5. You're going to get x is equal to 2. X is equal to 2. Okay? This is what we're going to be doing today. So you're probably wondering, okay, why on earth do we need this if we're in our geometry unit? So in your notebooks, real quickly, open it up to our next page, which I believe is page 30, is it 32 or 31 or something like that? 33. Thank you. So we're going to open up to page 33. And I'm going to show you why this is so important. What kind of angles are these? Again, I should see a lot more hands raised up because you are going to have questions just like this on your test, and we've been doing nothing but these kinds of problems. Alex, these are vertical angles. Vertical angles. They are directly across from each other. And more importantly, they are equal to each other. These angles are congruent. So that means when I set up an equation, I can set it up as 5x minus 9 is equal to negative 3x minus 25. And then I can work it out. So you will have problems in which you will be given vertical angles, and they might have variables on both of them, and you would have to solve. But you know how to. 5x is positive. The negative 3x, that's negative. Negative is always the smallest value, so we're going to go ahead and add 3x to both sides. That's going to give us 8x minus 9 is now equal to negative 25. We would then add 9 to both sides and get 8x is equal to negative 16. And then the inverse of multiplication, remember when it's a number side by side with a variable, that's multiplication. The inverse is to divide. So we would divide both sides by 8. We would get x is equal to negative 2, and we would be done. So vertical angles will, at times, utilize the variables on both sides equations process. We're going to do one more example, and I want you guys to do this one on your own. Be prepared to be called on. Okay, Alexander, what did you get for this problem? You're still not done? Okay. Who is done? Raise your hand if you are done. I haven't called on you two yet, so we'll go with Allison. Allison? Not quite. We'll have to see what mistake you might have made there. Matthew, what did you get? X equals 5. That's correct. So let's go through and see what the process was, okay? So here, we've got to set it up as negative 3x, or sorry, negative 3 times the quantity of x plus 4 is equal to 2x minus 37. So the first thing that we want to do is distribute. Okay, we need to distribute negative 3 times x and negative 3 times 4. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. So you get negative 3x minus 12 is equal to 2x minus 37. Okay, now we're going to focus on the smaller of the two variables. Negatives are always smaller than positives, so I'm going to focus on this by adding 3x to both sides. Right? The opposite of a negative is a positive, so plus is positive. Those will cancel out. We're going to be left with a negative 12. That minus 12 comes down like a negative sign. That minus sign has to come down and now takes on a negative sign. 2x plus 3x is 5x, and then you have minus 37. If you would like to rewrite it, you can rewrite it as 5x minus 37 is equal to negative 12, and then solve from there. We would add 37 to both sides. That's going to give us 5x is equal to positive 25. Then we would just divide both sides by 5 and get x is equal to 5. Okay? Did you see where you made your mistakes? Okay. All right. What you're going to be doing now, you're going to go to Google Classroom, and you have an escape room that you're going to do. You need to put your first and last name into the escape rooms where it says type your name. Then you're going to answer each of the puzzles, and you're going to type your answer code in all capital letters without any spaces. If you get the code right and you hit next, it'll let you go on to the next puzzle. If you get the code wrong, it'll prompt you to try again. You have to complete the entire puzzle and then hit submit at the end in order for you to get credit. So you either get a 100 or you get a 0. Because you either completed the whole thing or you don't complete it at all. Okay?